So we're multiplying a polynomial by a monomial. So a multi-term by a single term. So first step. Okay, so step one is to distribute the monomial. That's really fat.
At least it's readable.
Okay, so step one, we're going to take whatever is here on the outside. We're going to multiply it by every term on the inside. And then step two will be to collect like terms, if there are any. Okay, so when I multiply -3 times a +7, I get -21. And then x squared times x squared is x to the 4th. And then -3 times -1 is +3.
Do you multiply the exponents by each other, or do you have?
Yeah, when these are being multiplied, when two common bases are being multiplied, you add the exponents. You multiply the exponents if you're raising to a power. So the negative times negative gave me the positive, and then x squared times x is x to the 3rd. And then -3 times 4 is -12, and then it's x squared, because there's no x's.
Where do you get x to the 3rd?
X squared times x.
Oh.
Now, in this instance, I have x to the 4th, x to the 3rd, and x squared. I don't have any like terms, so I'm done.
Can't see. Like your black numbers.
They're blue.
Like I can't see the text. Not right. Yeah, not your right.
So I'm going to distribute this 5a squared to each term inside. There's 3 terms, so do 3 multiplications. 5 times -4 is -20. A squared times a squared is a to the 4th. I'm adding. 5 times 2 is 10. A squared times a is a to the 3rd. And then 5 times -7 is -35 a squared.
Almost like the first one.
Yeah, it's almost exactly like, except in this case we multiplied by negative, and here we multiplied by positive. And then here we have a 4 term. So I'm distributing 4 times. -6 times +3 is -18. D to the 3rd times d to the 4th is d to the 7th. It's a d. -6 times -2 is +12. D to the 3rd times d to the 3rd is d to the 6th. -6 times -1 is +6. D to the 3rd times d is d to the 4th. And then -6 times -9 is +54. And I get d to the 3rd.
Here's another question.
Yeah.
If you have a polynomial.
Multiple things. So we're going to multiply and add, or multiply and subtract. So the first step is to distribute the monomial. Okay. Now, this one, that one's so easy. That's 2p. So I'm just going to multiply 2p times both of those. But here it's -5. So I'm not going to multiply 5 times both. I'm going to multiply -5. So this minus has to stay with that 5. Okay, so be really careful of that. So when I distribute in, I get 2 times -4, so that's -8 p to the 3rd. And then 2 times 5, so that's 10 p squared.
What?
Oh, I see.
I'm doing 2p times -4p, and then 2p times 5p. And then over here, I do -5 times 2p squared, so that gives me -10 p squared, and then -5 times 20, so it's -100.
Don't you That's like like terms in the middle, right?
Yeah.
Mm. Yeah.
Okay. Our like terms are already together, so we don't have to rearrange anything.
Mm.
10p and negative 10p are like terms. Sorry, 10p squared and negative 10p squared. And they cancel each other out, right? 10 minus
So
10.
you're just left with negative 8 to the p to the third and minus 100.
Minus 100. And then that is completely simplified because we've collected all of our like terms and we've combined them and nothing else matches. So we have multiplication happening, we have multiple variables happening, and then we also have some simplifying that's going to need to occur. So here I have 15t times 10y to the third t to the fifth, and then times 5y squared t. So 15 times 10 is 150. There's no extra y's, so I just write the y's down. And then t times t to the fifth becomes t to the sixth. And then 15 times 5 is 75. Y squared t squared. Okay, so when there are no y's to be multiplied, you just carry them down the way they are.
Does it say y to the third?
Yeah, y third t6. Then if I have the negative 2y, don't forget this negative has to stay together. So I'm multiplying negative 2n. So negative 2y times y t squared, so that's minus 2y squared t squared. No t's, so I just carry them down. And then negative 2 times 4 is going to be minus 8. And then y to the third. Okay. And again, just by happenstance, my like terms are sitting right next to each other. The 75y squared t squared and the negative 2y squared t squared. So I'm going to simplify those.
73y squared t squared?
So I bring down the 150. Y to the third t to the sixth. Plus 73y squared t squared minus 8y to the third.
Or cubed.
Cubed, yes. First you need the formula for the area of a trapezoid. And there are two ways to look at that formula. There's the traditional which is area equals 1/2 the sum of the bases times the height. Or, if you don't like fractions, multiply the bases, or add the bases, multiply by the height, and then divide by 2.
That's just a bigger fraction.
No, this is division.
AKA fraction.
So, the bases are the two parallel sides. So this would be B1, and this would be B2. So the two parallel sides are the bases. And then the height is, well, the height, and it's always going to be at a 90-degree angle to one of the bases. So the flat bits are the bases. So to find the area of this trapezoid, I have to multiply the two add the two bases and then multiply them by the height. So base 1 is h plus 1. Base 2 is 2h plus 4. I'm going to multiply those by 18. And then I'm going to divide them by 2.
Yikes.
Now, we need to add these two binomials. So h plus 2h is 3h, right? h 2h and 2h gave me 3h.
So 3h plus 5.
And then 1 plus 4 gives me 5. Times 18 and then divided by 2. So I'm going to multiply each of these by 18. And then I'm going to divide it by 2, or I can divide this by 2 and then multiply by that. Which would you prefer?
Divide the 18 by 2.
So let's undo that. And let's do this part first. 18 divided by 2?
9. No.
Times 9. Now I'm going to multiply in.
27h plus 45.
So the area of this trapezoid is 27h plus 45. We have no idea what h is, so we're done. Any problem when you see things sitting right next to parentheses, the very first step is always going to be to distribute. Always. So we're going to distribute here, 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 and here. So 2a times 5a is 10a squared. 2a times negative 2 is negative 4a. 3a times 2a is 6a squared. 3a times 6 is 18a, and then there's that plus 8. I'm going to have to rewrite this. I'm running out of space. Yeah, I am. Sorry. Okay. Hold on. Let me switch colors.
No, we can go in between the step 1 and step 2.
No, no, that'll be too confusing. Yeah, all I did is rewrite this squished. So 4a squared, a times 1, sorry, that's not even right, is a. And then plus 12a squared minus 8a plus 50. Okay, so now I've done all the distribution. I want to put my like terms together on each side. So I have 10a and 6a. So I'm going to write those next to each other. Or sorry, 10a squared and 6a squared. And then I have negative 4a and 18a. Those are like terms. And then there's this lonely 8. Then I have 4a squared and 12a squared and a minus 8a and then a lonely 50. So I've rearranged it so all my like terms are together. You don't actually have to do this step if you're good at combining like terms without rearranging.
With the negative 4 to the 18, would it be minus or would it be higher?
Positive, because you keep the sign of the bigger
No,
number.
no, I mean, would you make the 18 go down or up?
Wow.
Like 14 instead of 24.
We'll find out.
Huh?
Ask you later. Want to know if the number will get bigger or smaller, like
No,
if we
okay,
solve it with
guys,
negative
if you
one.
have a negative and you're adding it to a positive, you subtract the two numbers, and then whatever number's bigger is the sign you keep.
Yeah,
So,
14.
10a and 6a squared gives me 16a squared. Negative 4 plus 18 is positive 14a plus 8. 4a and 12a is 16a squared. A minus 8a is negative 7a plus 50. Okay, now I need to move all of my variables to one side of the equation. Do you want them on the right or the left? You want them on the right?
Yeah, the
Okay. That's going to make them negative, but that's cool. All right, 16a squared. I'm going to move it, so I'm going to subtract it. And look what's going to happen.
cancel.
16 minus 16, 16 minus 16.
Goner.
They're gone.
And then we got
That leaves
7A.
me
That would be 7, I think.
It would be positive 7a.
Now, do you want to move this 7 over here or the 14 over there?
14 over there.
Okay.
That'd be.
No, shouldn't the 7 go to the left?
Yeah, if
It's
you want,
negative.
yeah.
Yeah,
Okay,
let's
we'll
put
move the
the
7 to make it positive. And 14 plus 7 is 21. Now this 8 has to go to the other side now. We had choices up until this point, now we don't have any more choices. So 21a equals 42. And then we multiply or divide as necessary. They're multiplying, so we're going to divide. And a equals 2.
Out of that big problem.
We are going to distribute 2x. And we are going to distribute 2x again. And so on this side, I'm going to get 2x squared plus 8x plus 7. Right? 2x times x gives me 2x squared. 2x times 4 is 8x. And then poor little lonely plus 7 just hanging out by himself. And then that x plus 8, nothing's happening to it, so I'm just going to rewrite it. And then I get 2x squared plus 2x plus 12. So far, okay?
Yep. The 2x squared can now disappear.
Kind of. Now we can get rid of things. On
2x.
this side, no like terms, so the left side will stay the same. But on the right side, I have a 2x squared. There's the only x squared, so that gets written down. I have x and 2x. So x plus 2x gives me 3x. And then I have
3x.
8 and 12. 8 plus 12 is 20.
3x.
Because of the 2x. The 2x.
X plus 2x. So then I'm going to subtract 2x squared from both sides.
I have 4x squared plus 19x plus 19. I must have done something wrong with the negative.
Did you
Oh,
multiply?
yeah, I put them all together.
Okay. Well, if I subtract the 2x's, they go away, right? Or the 2x squareds, rather. So I'm left with 8. Well, I don't want red, thank you.
You're left with
8x plus 7 is equal to 3x plus 20. So if you guys want to subtract 3x or subtract 8x? You choose. Okay, subtract 3x.
5x.
Which gives me 5x plus 7 equals 20. And then I'm going to subtract 7. And I'm going to get 5x equals 13. And then I'm going to divide by 5. And you guys are all going to go, oh my god, no, it doesn't go evenly. And I'm going to go, so what? Look, watch. Just leave it exactly like that.
In the case of that, all you can do is just
If
remove
it doesn't divide
5.
evenly and it doesn't reduce, then leave it alone. Just write it the way it looks.
It's like you didn't even have to put the divided 5s, you just had to erase the x. Erase the
FOIL is probably the most well-known method for multiplying binomials, and FOIL stands for the order that you multiply in.
cursive.
FOIL
again.
is first, outside, inside, last. And what that stands for is that I'm going to multiply the first terms in the binomials first. So this is first, 2x times x. gives me 2x squared. And then I'm going to multiply the outside with orange. Outside, 2x times 5 is 10x. Orange, okay, yellow doesn't work, so we'll go to green. Then I multiply the inside. So 3x. And then I do the last.
You got
3.
the X.
Oh, I did forget the x. 3 times 5 is 15. Okay, when I do this, my like terms end up in the center together. And I get 2x squared plus 13x plus 15. So for some people, the table's nice because it's very
Organized.
visually organized and geometrical, and so like looking at it, it's nice, it's square, it's pretty, so for some people foil's better, for other people the table is better. So to do the table, what we do is, it's like the multiplication table. So we write one of our terms across, or one of our polynomials across the top. So 2x and 3, x and 5. And you'll notice I'm keeping the plus. The reason I'm keeping the plus is so that when there's a minus, you keep the minus and get your signs correct. You don't necessarily need to keep the plus, but if there was a minus, you want to be careful of that.
Don't screw it up.
And then you just draw boxes. And it works exactly the same way a multiplication table does. In a multiplication table, we multiply this number times this number to get this number. So I'm going to multiply x times 2x, and I'm going to get 2x squared. And then I'm going to multiply x times 3 to get 3x. 5 times 2x gives me 10x, and 5 times 3 gives me 15. Like terms will generally line up on diagonals. So that's really nice. So your like terms are on nice, pretty diagonals. And then you collect everything together. I get 2x squared. That's my first term, will always be in this upper corner. Then I add my like terms together. And then my last term is in this bottom corner. Vertical is nice because it looks like normal multiplication, like if you're used to doing long multiplication. And so I write 2x plus 3 times,
X plus 5.
and I'm going to do a star instead of an x.
X plus 5.
X plus 5. And I multiply 3 times 5 is 15. 2x times 5 is 10x. 10x. And that's positive. And then I have to put a 0 for placeholder the same way I do with multiplication. And then I do 3 times x, which is 3x. And 2x times x gives me 2x squared. And then I add down the same way I do with normal multiplication. So that's the vertical method.
Do you have another example of the vertical?
Yeah, I can do another example of vertical. Let's do it down here. Okay. Actually, hold on. FOIL, we're going to do first. So that's 3x squared. Let me write that lower, actually. And then we're going to do outside. So plus 4x inside minus 6x, and then last, so minus 8. 4 minus 6 is negative 2, and we're done. Or you could do table. So x minus 2, 3x plus 4. 3x times x is 3x squared. 3x
Bless
times
you.
negative 2, bless
Bless you.
you,
Thanks. Okay.
is negative 6x. 4 times x is 4x. And 4 times negative 2 is negative 8. Again, our like terms are nice and pretty and line up on diagonals for us. So I get 3x squared minus 2x minus 8. Okay. Or if you like method 3, x minus 2 times 3x plus 4. Negative 2 times 4 is negative 8. X times 4 is 4x. I'm going to put in my space holder. Negative 2 times 3x is negative 6x. X times 3x is 3x squared. And then I add straight down. Method 1 is a modified FOIL. It's not a true FOIL because it's not a first, outside, inside, last, but it's using basically the same general idea. So what I'm going to do is we're going to make kind of some rainbows. So let's start with red. And check on things. Okay, so I'm going to do 6x times 2x squared. And that's going to give me 12x to the third. And then I'm going to do 6x times negative 3x, which is going to give me minus 18x squared. Then I'm going to do 6x times negative 5, which is going to give me negative 30x.
Wow.
So I've done 6x times each of these. Now I do 5. 5 times 2x squared gives me plus 10x squared. 5 times negative 3x gives me, I'm just going to move down a little so we have more space, so sorry about that, but negative 15x. And then
Negative 25.
5 times negative 5. So we have negative 25.
And not a single one of those.
Okay, then I need to combine my like terms. 18x squared and 10x squared are like. Negative 30x and 15x are alike. So 12x to the third is by itself. Then the x squareds, I have negative 18 plus 10, so that gives me negative 8. And then I have negative 30 and negative 15, so it's negative 45 and then minus 25. So that's the modified FOIL. And that will work for any size. If I do a 3 by 3, I just have to do 3 lines off of each of the first 3 into the next 3. And so you can see how it can get a little bit, eventually you'll have these lines going all over the place and it can be kind of visually confusing. That's why I don't usually use it. That's just me though. If the lines don't bother you and you like this method, you can use it. I like tables for this one.
So would it be like 3 across and 2 down?
Or 2 across and 3 down, however you like it. I'm going to do 2 across and 3 down to make it skinnier. It doesn't really matter. You just have extra boxes. So 2x squared times 6x gives me that 12x to the third. 2x squared times 5, bless you.
Bless you.
10x squared. Bless
Bless
you.
you.
Negative 3 times 6 is negative 18x squared. Negative 3x times 5 is negative 15x. Negative 5 times 6x is negative 30x, and negative 5 times negative, or positive 5 is negative 25. And you can see we still have like terms on diagonals. So I get 12x to the third minus 8x squared minus 45x minus 25. So same answer, just different method. And again, if you like this one better, use this one. If you like this one better, use this one. And then we'll try the next one. And if you like that better, use that one. Now on method 3, I would always recommend that you put whichever polynomial has the most terms on top. It won't matter if they have the same number of terms. But so I'm going to put the 2x squared minus 3x plus 5 times 6x plus 5. So I have 5 times, oh, that's minus 5. Yeah.
Can I get the paper towel over there?
Yeah, go right ahead.
Like you see.
Yeah, no, go right ahead. Negative 5 times 5, negative 3 times 5, 2 times 5, placeholder, negative 5 times 6, negative 3 times 6,
Just in case I sneeze.
2 times 6, I kind of ran out of space there, sorry, and add everything together. And you get the same answer. So, modified FOIL. Ready? 2y times 3y squared is going to give me 6y to the 4th. I'm just going to go ahead and write in all the colors. Be pretty. 2y times, that's supposed to be purple. 2y times negative 5y, that gives me negative 10y to the 3rd. Two y times 2 gives me 4y squared.
It's kind of like a negative distribution.
3y times 3y squared gives me 9y to the 3rd.
Everyone gets a piece.
Three y times negative 5y gives me negative 15y squared.
Got a rainbow of colors.
3y times 2 gives me 6y.
Good.
We're not done yet.
Because there's that negative 1.
Yep. Negative 1 times 3y squared gives me negative 3y squared.
Wow. I don't think you're going to have enough room.
Negative 1 times negative 5y gives me positive 5y. And I need one more color. Gray.
I thought you picked it gray.
Negative 1, so minus 2.
Wow.
Can you imagine if you're doing a 4x4?
On a page this big, maybe?
Okay, so like terms, I only have one y to the 4th, so that goes right here.
Yay.
Negative 10y to the 3rd.
And negative.
And positive 9y to the 3rd gives me negative y to the 3rd.
And then you have 3 to the 2nd.
4y, negative 15, and negative 3 are all y squared. So 4 minus 15 is negative 11. Minus 3 is negative 14. Right? 4, negative 11,
So you're adding
negative
that?
14. They're both negative.
Oh, okay.
So it's like debt, like if I borrow money and then I borrow more money.
Okay.
Does that make sense?
Okay.
Okay.
Not really, but okay. And then
I owed you
this-
$15 and I had 4, so I
and
paid
the
you back, but then I
11Y.
borrowed 3 of it.
Then the 11y. And then negative 2.
Yeah. Then I have the 6y and the 5y, so that gives me 11y.
And then the negative
Minus
2
2.
all by himself.
Okay, so that's method 1.
Can we not do method 2 and 3?
Yeah, we'll do method 2, it's easier.
It's a big box. No, I'm just saying it's a big box. And I just remembered why I hate math.
6y to the 4th, 9y to the 3rd, negative 3y squared, negative 10y to the 3rd, negative 15y squared, 5y, 4y squared, 6y minus 2. Your like terms are still on diagonals. So 6y to the 4th, negative 10 plus 9, so minus y to the 3rd, 4 minus 15 minus 3, 6 plus 5, and then minus 2. Okay, special products.
Bless you.
Squares.
That's the worst allergies.
Square of a sum. If I take two things and I FOIL them, one thing, and I square it, so it's itself times itself. This, AB squared. A plus B squared, I should have put this step in there, sorry. A plus B squared is A plus B times
Not
A
recording.
plus B. Yes, I am.
Oh, okay. Couldn't see that.
Okay, so A plus B squared is A plus B times A plus B. And if I FOIL it all out, I get A squared plus AB plus AB plus B squared. And AB plus AB gives me 2 times A times B. So if you see a square, you don't have to do all the FOILing and the tabling and all that stuff. You can just do the pattern. And the pattern is to take the first term and square it. Then I take these and I multiply them together times 2, and then I square the last term. So I get x squared plus 6x plus 9. And I don't even have to write this out because I can do like x squared in my head, and then I can go 2 times 3 times x. I can pretty much do that in my head. And then 3 squared I can do in my head.
What?
You square the first thing.
Alright.
And then you take 2 times the first times the second. Oops, sorry, that's not 8D, that's 3D. And then you square the second. So I take the first 8c and I square it. 8c squared is 64c squared. And then I say, okay, 8 times 3 is 24 times 2 is 48, and then CD, because there's a C and a D there. And then I say, okay, 3D squared is 9. 3 squared is 9.
So it's
So
not
2 8c times 3d, where did that come from?
Pattern. 2 times the first thing times the second thing.
So in the case of this,
Oh.
Here, let's do another one that's fairly simple, like that.
it's kind of like just
Square the first
multiplying
term.
everything.
Okay. Square the first term. Multiply these two together. That's 5x times 2. Square the second thing.
So
So
it's like do the
I'm going to
problem
square the
and
first
multiply
thing.
the thing.
Square the first thing.
Then you do the
Okay,
problem.
multiply them together. That's 12xy times 2. And then I square the second thing.
16y.
16y squared. So square the first, multiply them together, then times 2, and then square the second.
S M S.
Sure. If that works for you. That would be S2ms.
So it's A times B times 2?
Yeah, in the middle. So I multiply, so like here I do 8c times 3d is 24cd
Oh.
times 2 is 48.
Alright.
Want to see another one?
Yeah.
2x plus
So-
5.
So you put them together and then you multiply it by the 2 on the
Yeah.
outside.
So square the first one. Multiply them together. 2x times 5 is 10x times 2.
Plus.
Square the last one. Yes.
Why for it with the 8 and the C, why didn't you put the 2 with the 8 and make it 64?
It's here. I did.
Oh, okay, okay.
Wait,
Just see.
where'd you get 20 from? The one you just did?
2 times 5 is 10. Times 2 is 20. It's always times 2.
Yeah.
So square it. Multiply them
Looks like you put a
together,
D
and then
next
times
to it.
2.
It looks like you put 20D. Yeah.
And then
Right.
square it.
Wait, if you wouldn't the x be a squared?
Alright, so you
No,
multiply
no,
them
no, it
together
wouldn't.
first.
On
and
the
then
first
multiply
term,
it
it's
by 2.
squared. In the middle, it's not. So, okay, square it the first. Multiply these together, and then multiply it by 2.
Alright, so you multiply them together first.
And then multiply it by 2, and that gives you this, and then square the second one.
And the value of variable is unchanged.
Yeah. One more?
No, thank you.
Yes, please.
More confusion.
Square the first.
Square that, so
So-
it's 9x squared. 21. 42.
X.
7 squared, 49. Alright.
Or you can FOIL it out. If it's a difference, there's subtraction. It's the exact same thing, sort of. The first term is still squared,
Just with
and the last term
opposites.
is still squared, and the middle term is still 2 times a times b, but it's minus. So I'm going to square the first.
So A 2
2 times 5 is 10, times 2 is 20,
and negative.
but it's
20.
minus. And then square the second.
Negative 10.
It'll be positive because it's negative times negative is a positive.
Between 2AB at the top and B2, is there supposed to be a plus there, or is it just like that?
Yeah, that's a plus, sorry.
Because you're.
So, same pattern, the only difference is if this is minus, this is minus. If this is plus, it's plus. So, square the first. Multiplying together, I get 6p times 2. This is negative, so that's negative. Square the second.
Alright. So it's the same thing, except
Yeah.
there's a negative.
Square the first. Multiply them together, that's 2ab times 2. So that's 4ab. Oops, I'm in my own way. So minus 4ab, and then square the second one. So that's 4b squared. Good?
Alright.
Okay, almost done.
Wait,
Sorry.
that's almost done.
That's fine. Product of a sum and a difference, which gives us a difference of squares eventually, which is kind of cool. So, whenever I FOIL this out, if I were to FOIL this out, I would get a squared plus ab minus b squared. Well, plus ab minus ab cancel each other out. So you get the square of the first minus the square of the second. So if you have identical except they have opposite signs.
So wouldn't everything in the middle just go?
Yep.
Kaput?
Square of the first minus the square of the second.
Wait, I don't get this one.
If I FOILed this out,
Oh.
right, it would be x squared minus 4x plus 4x minus 16.
So you just get rid of the stuff in the middle.
These cancel. So you're just left with the two ends. So it's the square of the first minus the square of the second. So square of first minus square of second. So 4c squared, 16,
So you only have to do the first two.
70.
You square 70?
Yeah, the square of 70, so that's 49.
So like that kind of, if you just.
So this is
Yeah.
square everything?
Square the first, square the second.
Square the first, square the second.
Put a minus in between them.
It would look like that.
And the reason I said is because the middle terms would cancel each other out.
And then you don't do anything with the 4c and the positive 70?
No, the 4c is the first, 70 is the second. They just match, except for
Oh,
the sign.
yeah.
I'm just ignoring the fact that there's,
Stuff in the middle.
yeah. Like I'm skipping this part in the middle. I'm doing first and last as opposed to outside inside. Like in the FOIL, I'm taking out the middle part that would cancel out. So I'm just doing first and last.
What do you mean?
So like this, multiply first and last.
So you're foiling it?
Yeah, that's foil.
Yeah, it would be FOIL, except the inside terms cancel each other out because these match, except for if I did 6, this would give me 3n times negative 2 would give me negative 6n. 3n times positive 2 would give me positive 6n. They go away.
Oh.
So there's no point in doing it. So the pattern is if you look at if they have the same numbers but opposite signs, you take the first thing you see, you square it, take the second thing you see and you square it and you put a minus in between them.
I see.
And then you don't have to do all the work.
Is it always a minus?
Yes, always a minus.
Plus the negative making negative.
Hmm? Yes, there's homework.
So I'm guessing if they were both negative, you would just like do the same thing.
If they were
but
both
plus the middle.
negative, it's this.
Yeah.
So the homework. Am I still recording?